Hey guys, I hate I'm not with you today, but I'm sure you can handle it without me. I'm going to go over 5, 6, and 7 on the bell ringers from last week. Yeah, we're still on last week's bell ringers. And we're going to do some new notes. It's page 19. Okay, let's see. For number 5, when I start counting, there are 1, 2, 3, 4 terms, so I'm automatically thinking grouping, but the first thing I should always think is there a GCF? And in this case, there is not. I thought 3 because of 6, 12, and 9, but 8 doesn't go into that. I thought 2, but 9 doesn't go into 2, so there's not a GCF, so I do get to go straight to grouping. I put each pair of terms in parentheses. Let me zoom in on that. And I asked myself, what do 8ax minus 6x have in common? They have a 2x, so I'm left with 4a minus 3. And then with the other two terms, negative 12a plus 9, what do they have in common? I could pull out a negative 3. And I would be left with a 4a minus 3. And I'm happy because these two terms match. So my final answer is 2x minus 3 times 4a minus 3. Okay, on the next one, there are 3 terms. I don't see a GCF, so we get to do normal factoring. I'm asking myself what 2 things multiply to give me the last term, what 2 things add to give me the middle term. So if you need to write that out, I need to know 2 things that add to give you 6, 2 things that multiply to give you 8, but hopefully you're getting faster and faster at this and can start doing it in your head. Things that multiply to 8, well 8 and 1, that doesn't give me the 6. 4 and 2, well 4 plus 2 is 6, so 4 plus 2 6. 4 times 2 is 8. So my answer is x plus 4, since I have a positive 4, and x plus 2, since I have a positive 2. Okay, the last math workshop question for today is number 7. Again, I see 3 terms, and I ask myself, is there a GCF? And this time there is. They all have an A in common. So if I pull out an A, I'm left with A plus 5 plus B. And that's all I can do. Okay, I hope you have your notes out. I don't mean to fly. If you want to play this video back, it should already be posted on Google Classroom as well, in case you missed something. Okay. In the notes on page 19. Today we're going to solve systems of inequalities by graphing. You liked graphing inequalities when it was only 1 equation. Today we're just going to graph 2, maybe more, and see where they overlap. We actually did a math workshop question like this the other day, and you rocked at it, so it should be an easy lesson. Okay, again, as we've been discussing, you want to graph something, you need it in slope-intercept form, so you need it in y equals mx plus b. But since we're talking about inequalities, we understand it may not be an equal sign, it may be a less than, greater than, etc. Okay, so my first equation was x plus y is greater than or equal to 4. When I subtract x from both sides, I get y is greater than or equal to negative x plus 4. Okay, so I go to my graph. I put my intercept at 4. 1, 2, 3, 4. My slope is negative, so down 1, right 1, down 1, right 1, down 1, right 1. And I can do it the other way. And then since it's an equal to, I get to use a solid line. And then since it's greater than, I'm going to shade above the line. But as always, if you want to plug in a test point to make sure we're shading correctly, it's never a bad idea. Okay, but today we're not done. That's great, but we've only done half of it. We have to rearrange the other equation as well. Okay, the other equation was 2x minus y is greater than 2. If I subtract 2x from both sides, I'll have negative y is greater than negative 2x plus 2. Many people at this point on their most recent test would just drop the negative sign. Don't know why that happens. Not something that we can allow. Instead, I'm going to divide by negative 1. And if you need to show dividing by negative 1, you can. And I get y, a positive 2x, negative divided by a negative is positive. 2 divided by negative 1 is negative 2. Oh, but since we divided by a negative, we have got to flip that sign. So it was greater than, now it's less than. So when I graph this line, I go to my intercept of negative 2. I count up 2 and over 1, up 2 over 1, up 2 over 1. It's just a less than, so I don't get to use a solid line. It's got to be a dotted one. And since it is less than, I want to shade below my line. So below this line would be over here. But again, if you want to plug in a test point to make sure you're not crazy, you can. Miss Brister's go-to is 0. And 0 is where I'm thinking we shouldn't be shading, so I should get something crazy. If I plug in 0, I would have 0 is less than negative 2. Well, that is crazy, so I do shade down here. Okay, but our answer is where these two regions overlap. So this little shape over here in this first quadrant, well, kind of goes into the fourth. That's our answer, where they overlap. Okay, let's go ahead, and we have a couple more to do just like this. On number 2, again, we're not in slope-intercept form, so we've got to rearrange our equation. If I subtract x from both sides, I'll have 3y is less than negative x plus 3. When I divide by 3, I get y is less than negative 1/3 x. 3 divided by 3 is 1. Okay, so I put my intercept at 1. My slope is negative 1/3, so down 1, right 3. Down 1, right 3. Up 1, left 3. Okay, and since it's just a less than, not a less than or equal to, when I connect the dots, I'm going to use a dotted line. Since it is a less than, I'm going to shade below my line. And now I have to deal with my other equation because it's not in slope-intercept form. Okay, it was x minus 2y is greater than or equal to 4. If I subtract x from both sides, I'll have negative 2y is greater than or equal to negative x plus 4. When I divide by negative 2 on both sides, I've got y, divided by a negative is positive 1/2. Positive 4 divided by negative 2 is negative 2. But the most important part is since I've divided by a negative, I have to flip my sign. So instead of greater than or equal to, it becomes less than or equal to. Okay, so I go to negative 2 on my graph. There's my intercept. My slope is 1/2, so up 1 over 2. Up 1 over 2. This time when I connect the dots, I am going to use a solid line since it is less than or equal to. Since it is less than, I'm going to shade below my line. But my answer is actually this region from here over to here, where they overlap, where you see green and pink. Okay, let's go ahead and do number 3. This is where life gets tricky because we forget about these straight line ones. Y is less than or equal to 1 is a straight line at 1 on the y-axis. So, looks like this. I get to make it solid because it's less than or equal to. Since it's less than, I shade below it. So I dealt with that top equation. It was really easy and fast. X is greater than 2. Well, here's 2 on the x-axis, so x greater than 2 is this line. I have to make it dotted since it's not greater than or equal to. Greater than implies I should shade above the line, but that's kind of hard to tell. So if you need to plug in a test point, like we could plug in 3, 0, well, 3 is greater than 2, so yes, I need to shade over here. And again, our answer is the region where these two shaded regions overlap. So it's down here in the 4th quadrant for the most part. Okay, we're almost done. There's only a couple more left. Flip to the next page. Two left. And look, number 4 seems awesome because they already have it in slope-intercept form. Hot dog. Okay, so I can just go straight to graphing on this one. My intercept is at positive 1. My slope is negative 3, 4. So down 3 over 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Since it's equal to, I get to make this a solid line when I connect those dots. Since it's a greater than or equal to, I get to shade above my line. So I've got the top equation graphed. I now have to deal with the bottom equation. So I'm supposed to go down to negative 2. Negative 2. And that's odd. My slope is the same thing. Negative 3 over 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. And yes, there is a reason they are parallel, and we'll get to that in just a second. I get to connect the dots with a solid line since it's less than or equal to. And since it's less than or equal to, when I shade, I'm going to shade below the line. Okay, so anytime you see two parallel lines in this graphing inequality section, you should probably be suspicious because it's probably something like this. If you notice, there is no overlapping with the pink and the blue regions. There isn't any. They're not overlapping any, which means there's no solution because there's not a spot where the pink and the blue both agree. So this is a problem with no solution. Okay, so again, be wary if you see two parallel lines in this section. They're probably this kind of a situation. Okay, our last problem of the day is number 5. Sadly, it's not in slope-intercept form, so I've got to rearrange. On the top equation, if I subtract 3x from both sides, I'll have negative 2y is less than or equal to negative 3x minus 1. I'm going to divide both sides by negative 2. I'll have y. Negative 3 divided by negative 2 is positive 3/2 x. Negative 1 divided by negative 2 is positive 1/2. But the most important thing is since we have divided by a negative, we have to flip that sign so it's greater than or equal to. Okay, this one stinks because our intercept is at 1/2. So we really just have to be a good estimator. So we get that between 0 and 1, 1/2 is about halfway in between. And then so when we count, instead of counting on the lines, we're going to count on the halves. So since my slope is 3 over 2, I'm going to go up 1, 2, 3. Note I'm still in the middle. Over 1, 2. Note I'm still in the middle. Up 1, 2, 3. Over 1, 2. Notice all my points are happening in the middle. Not actually on a where we normally would like to be, but in the middle. Down 1, 2, 3 over 1, 2. 1, 2, 3 over 1, 2. Since it's greater than or equal to, I get to connect with solid line. And I hate to break y'all's heart, but the fact that it was 1/2 actually made this pretty easy. I've had to deal with like a 1/8 or a 1/4, and you still have to commit and graph it as best you can. Okay, so let's see. Since it is greater than or equal to, we get to shade above our line, so we're going to shade over here. So we've got that line done. We still need to deal with that second equation. It's not in slope-intercept form, so we've got to rearrange it. I'm going to subtract x from both sides, and I'll have 4y is greater than or equal to negative x minus 12. When I divide by 4, I get y is greater than or equal to negative 1/4 x minus 3. If you were here with me, I would ask you, well, you would tell me you couldn't see what I was doing, first of all. But I would ask you why we didn't flip the sign this time. And I pray you would tell me it's because we didn't divide by a negative. Okay, with this new equation, my intercept is at negative 3. So I've got to go down to 3. 1, 2, 3. My slope is negative 1/4. So up 1, left 4, 2, 3, 4. Up 1, left 1, 2, 3, 4. Down 1, right 1, 2, 3, 4. Down 1, right 1, 2, 3, 4. Okay, and then since it's greater than or equal to, we do get to connect the dots. Since it's greater than or equal to, we get to shade above the line. So this overlapping region would be the answer. And I know that's the last problem, but I still feel like my geniuses in the room need a little more clarification. Okay, so there might be an overlapping region. We pray there is. And if there is an overlapping region, that's the answer. We could have a scenario not like number 4 where there is no overlapping region, so there's no solution. We might run into a situation where we end up graphing the same line and shading the same region. If that happened, of course, it would be infinitely many. But they don't put a lot of those out there because there's no fun in that. Infinitely many answers just aren't as fun in this section. But I mean, they do exist. So don't think just because we didn't work in infinitely many doesn't mean it can't happen. Okay, well, you have a checkpoint I need you to take, and you need to turn it in by the end of the class period. When you get completely done with all the things, why don't you work on your coloring page that you received on Friday? If you weren't here on Friday, figure out the date from Friday, get it out of the crate, use your brain. Just because I'm not here doesn't mean you don't have a brain. Okay, have a good day, guys. Bye.